In this video, I want to do another limiting reagent example. So we're given this chemical equation, along with the masses of the reactants, as well as the molar masses and the moles of the reactants, which I converted. And we're asked to determine how many grams of the product will be produced, and also how many grams of the excess reactant will remain after the reaction has taken place. So the first thing that we have to do is we have to identify the limiting reagent, because that in turn will determine the amount of product that will be formed. And we determine the limiting reagent by using our limiting reagent calculations. And when doing these calculations, what we do is we choose a reactant. It doesn't matter which reactant. And by choosing that reactant, we're basically seeing what will happen if that reactant does turn out to be the limiting reagent. And we usually only do one calculation for that one reactant, but when given a problem such as this, where we're asked to determine the amount of the excess reactant, I actually do calculations for both of the reactants. So let's look and see what will happen if we say that the acetaldehyde is our limiting reagent. So we use the given amount of acetaldehyde, and we use the mole ratio between acetaldehyde and oxygen to determine the stoichiometric amount of oxygen that's required to completely react with the acetaldehyde. And if we do this calculation, we'll see that the amount of oxygen that's needed is 0.454 moles. And we see from above that the amount of oxygen that we have exceeds what we need. So therefore, we can say that the oxygen is our excess reagent, and therefore the acetaldehyde is the limiting reagent. Now, if we look at the oxygen instead, we'll still end up with the same answer, but as I said, this is useful later on. Anyway, so using the amount of oxygen that we're given and the mole ratio between oxygen and acetaldehyde, we see that the amount of acetaldehyde that's required to stoichiometrically react with all of the given oxygen is 1.25 moles. And from above, we see that the amount of acetaldehyde that we actually have is less than that is required to completely react. So therefore, we can say that acetaldehyde is the limiting reagent, and oxygen is in excess. And this is exactly the same that we showed on this side as well. So to answer the first part of the question, how many grams of the product will be produced, what we have to do now is we have to take into account the limiting reagent, because the limiting reagent will determine the maximum amount of the product that can be formed. So to determine the mass of the ethanoic acid that's formed, we once again use the amount of the limiting reagent, the molar ratio between the limiting reagent and the product, and then the molar mass of the product to determine the final mass of the product that's formed. And if we do this, we find that the mass of ethanoic formed is 54.5 grams. Now the final part of the question is asking us to determine how many grams of the excess reactant will remain. And as I said before, this is quite easy to do now because we've done two limiting reagent calculations. And in order to determine the excess amount of oxygen formed, we look at we'll look at this calculation here, in which we calculated the stoichiometric amount of oxygen that would be required to completely react with the limiting reagent. And we see that we needed 0.454 moles of oxygen to completely react. But we had a lot more, so we take the difference between those two values. And if we do that, we end up with 0.171 moles of O2 in excess. We convert that to a mass through our molar mass of oxygen gas. And if we do that, we end up with a value of 5.47 grams of excess oxygen gas.